Ladies and gentlemen, please welcome the distinguished engineer, Anders Hejlsberg.
Thank you very much. I'm going to start my talk today with a little bit of a historical perspective to sort of take you from the early days of computing to where we are now. I'm sure if you look back at the history of computing and distributed applications, you'll see that every decade or so there's a shift in the center of gravity. Going back to the 70s with mainframes, we did all of our computing on a server in the back room and connected with proprietary protocols and dumb terminals. And then in the 80s, the center of gravity shifted toward computing on the client. In fact, file servers would just sort of serve up files. There wouldn't be a lot of computing happening on the server. It would all happen on the client. Now in the 90s, with the internet, the center of gravity basically shifted back to a server model. The net is very much like really an old IBM 3270 terminal, except you can connect to multiple different sites instead of just one server in the back room, and of course HTML is a much richer protocol. Now people have talked about how maybe now the time has come for another shift towards the client with peer-to-peer computing. But we actually think that this time, in this decade, we're gonna finally see a balance. We're gonna have both computing on the server and on the client. We're gonna be able to still do a lot of stuff on the server like we do today, but also take advantage of some of the innovations that are sure to happen in handwriting recognition and speech recognition on the client. In other words, we think we're going to be able to have the best of both worlds. And the reason we think so is that we finally have a protocol set and infrastructure that allows us to have intelligence on both ends of the wire. And that's XML and web services. Now, it's interesting to note with XML web services how sorry, spacing out here for a second. Sorry about that. One of the things about XML web services, of course, is that a shift of that dramatic nature. If you look at the vision for .NET, it's about information anywhere on any device at any time. But really, no matter who you ask about their vision for distributed computing, it's all about, or their vision for computing in the future, it's all about distributed applications, connected applications. And we believe that XML and web services are going to be the infrastructure for these distributed applications. But of course, a shift like that also takes a new tool set. And looking at where we are today, here's sort of a little bit of the history of the tools that have led us today with, each of the previous decades really sort of had their own tool sets with text mode applications, GUI applications, and then leading up to the internet. And the next set of tools in that evolution is what we're here to talk about today. It's the .NET Framework, Visual Studio.NET. Now, when we shipped Visual Studio 6.0 about 3.5, 4 years ago now, we knew that we had built a great tool that was going to enable you, our customers, to build great solutions, but we also knew that in some of the areas of the tool we could do better. For example, we really realized that the model for building distributed and connected applications simply was too complicated. But if you look at the technologies that people have used up until now to build distributed apps or connected apps, it's been technologies like DCOM or Corba, IIOP, RMI, you name your favorite protocol. But I think all of those tools are sort of characterized, or protocols are characterized by the fact that the distributed applications are hard to build, they're hard to deploy, and they're hard to maintain. We knew we could do better. We also knew that we had too many different programming models and too many different programming languages that didn't really interoperate. You know, we have Visual Basic and C++ and ASP and so forth. We knew that our object system, COM, in many ways was not rich enough to do what people want to do in their programming today. COM doesn't support key object-oriented concepts such as inheritance and polymorphism. And at the same time, we knew that COM was too complicated. COM is a very low-level binary standard. There's a lot of housekeeping that you have to do yourself with COM, you know, worrying about H results and add refs and releases and GUIDs and so forth. At the same time, we were seeing sort of the internet grow leaps and bounds, and we knew through our work with XML and the the W3C consortium where XML has been standardized, we knew that this was going to be the fabric upon which this new class of application was going to be built. But looking at all of these factors together, we also realized that we weren't really going to be able to get there in an evolutionary way of just sort of modifying COM and DNA a little bit. We knew that we had to build a new platform. And that new platform is the .NET framework. It's a platform that natively supports XML web services, that unifies our many programming models, that dramatically simplifies development, provides a robust and durable, secure execution environment, supports multiple programming languages, and finally allows you to interoperate with the code that you have already written and put resources into. Now, before I show you how we built the framework and drill into some of these bullet points here a little bit, let me first give you a block diagram overview of what the framework is. It starts with, at the bottom, the operating system, and on top of that, we have what we call the common language runtime. This is a component that in day-to-day use of the framework, you don't actually see this component. It provides all of these sort of core system services such as class loading, JIT compilation, exception handling, garbage collection, security, et cetera, et cetera. So it's sort of this black box that allows you to execute code in the .NET world. On top of the common language runtime, we have a whole set of class libraries, starting with the base class library that provides a bunch of common functionality such as file I/O, string handling, access to TCP/IP, for example. Built on top of that, then, we have ADO.NET, which is the next generation XML web service enabled version of ADO, and also our XML stack that starts all the way down at a low-level XML parser, works its way up through a W3C DOM compliant XML document model, and also supports, XPath and a bunch of the other XML standards. At the top of the class library stack, we sort of have two buckets then. We have the server-side bucket and the client-side bucket. In the server-side bucket, we find ASP.NET, our application server, Web Forms, which is our programming model for writing forms in ASP.NET, support for web services, and the mobile internet toolkit that allows you to build UI for mobile devices. And on the client side, we have Windows Forms, which is, in a sense, you can think of it as an evolution of Visual Basic Forms and MFC, sort of put together. You get the best of both worlds in Windows Forms. Now, further on top of that, we have this thing that we call the Common Language Specification. And what that really is a standard for the minimum set of functionality that languages must support in order to be implemented on the .NET Common Language Runtime. And supporting that Common Language Specification, we are ourselves shipping 4 languages, Visual Basic, C++, C#, and J#, but industry partners are building, at this point we have in excess of 20 languages supported on the runtime. And then finally, of course, supporting the entire stack is the development tool Visual Studio.NET. So let's take a little closer look at how we built this and what were sort of some of the key drivers in creating the framework and Visual Studio. I talked about how up until now we have had too many different programming models. And the way to think about this problem is really, again, to take a historical perspective and look back at how we used to write Windows applications. If you go back, say, 10 or even 15 years, writing a Windows application, there was really only one way of doing that. You would fire up your C compiler, you'd pound include windows.h, you'd look in your pet's old book, and you'd write WinProcs and Windows message handlers, and it was all quite complicated and not particularly productive. And so over time, we've seen a number of different programming models come to light. For example, Visual Basic pioneered the notion of rapid application development with composition of forms, where you drag controls from a tool palette onto a form, and you delegate to event handlers and write code behind in that way. But C++ took a different route with MFC and ATL. Here we sort of use different paradigms such as subclassing, and while this might give you more power and expressiveness, it's certainly not as easy to use as Visual Basic. And then most recently with the internet, we've seen a whole new programming model spring up around stateless code in HTML pages that execute on the server, the ASP programming model. And you could certainly imagine that we would just keep going and have a new programming model for writing web services and a new programming model for writing mobile UI. But there are some unfortunate facts about this sort of evolution here. One is that your choice of programming language or programming model, your choice of programming model inadvertently also becomes your choice of programming model. Of language. I'm really confusing here. For example, if you think about MFC, if you're a VB programmer and there are features of MFC or ATL that you would like to know, to use, it's just not possible. Likewise, VB forms can only be used from Visual Basic, and if you want to write code behind an HTML page, well, it has to be script. Another problem is that each of these different programming models have solutions to common problems that differ amongst them. So, for example, in each of these different programming models, there's a way of doing file I/O, but it's different between all of them. Now, what the .NET framework does is it unifies all of these programming models to give you consistent API availability, regardless of what your programming language is and regardless of what your programming model is. Now, I talked about how another goal for the framework was to dramatically simplify development. And there are so many ways in which the .NET framework does that I can't even enumerate all of them, but I've sort of put some of the high-level bullets on this slide here. First of all, I think the thing that the .NET framework does is it moves up the level of abstraction. If you look at COM today, it's a very low-level binary standard. I don't know if any one of you have ever done programming with C++ and COM, and it's horrible. You have to deal with H results and GUIDs and addrefs and releases, and there are just every place you go, there's ample opportunity for bugs to sneak in. And as I said, COM really isn't rich enough today either. It doesn't support the core object-oriented concepts. The framework really does away with all of that plumbing. It simply automates it completely and frees you to think about the algorithms instead of thinking about the housekeeping. Another example here is how the framework provides a unified type system. In the framework, everything can be treated as an object. Even an int can be treated as an object or a float. There are no variants, rather everything is objects. So there's no dichotomy between objects and variants as you might have sort of come across in Visual Basic. There's one string type for the entire platform, and all character data is Unicode. Finally, the platform provides support for component-oriented programming or software component. Things like properties and methods and events are all first-class constructs in the .NET framework. So it's not like if you use C++ to create an ActiveX control, for example, there's all sorts of macro stuff you have to do to define its properties and its events and so forth, but it's all natively built into our languages in the .NET framework. And another final point would be the way our APIs are organized. It used to be with the Win32 API that really it's an enormous flat API. There really isn't any organization there. About the best we could do is, you know, take these 30,000 entry points and sort them alphabetically, you know, but if you look at the framework, everything is organized into logical namespaces. So if you're looking for something having to do with I/O, you would look in system.io, and there you would find a class called file, and it just sort of takes you to the place that you want to go. One way of looking at the simplified development is also to sort of look at what you would write before and what you write today. Here's sort of one of my favorites, a little example of what it takes to create a window using the Windows API. You first have to call create window EX and pass it no less than 12 parameters, and then you have to show window and update window in order to show it on the screen. Compare that to what you do with the framework. You create a form, you set its caption, and you show it. Now, a lot of you I know are VB programmers, and you're going, we've had this for years. What's new here? I think, though, that there are several things that are new if you compare it to VB today. First of all, with VB today, in order for you to get these easy APIs, someone had to first write a wrapper around the APIs, turning them into COM APIs. That's sort of why VB has lagged behind. Often when new system APIs come out, they come out sort of in the C style of programming, and then the VB team first has to wrap them and turn them into sort of easy to use APIs. A second problem, of course, has been that once these APIs do get wrapped, you're not really speaking the same language as the other guy that talks about the low-level API, and the documentation doesn't really apply, and some things didn't get wrapped, and therefore you're missing this and that and the other favorite feature of yours. But I think perhaps most important is that this is the way we will author APIs at Microsoft going forward. There's not going to be any of this low-level gobbledygunk anymore. We are moving the abstraction level up and writing APIs that are easy to use, where you can pay as you go, so to speak, and not have to understand the entire API before you can write the simplest application. I think another key thing that the .NET framework provides is a robust and durable execution environment. In the .NET framework, all objects are garbage collected. Memory management is automatic. Now, there's actually a difference here between how memory management works in COM and how it works in the .NET framework. In COM, there's also automatic memory management, but it's done with a methodology called reference counting, where you count the number of references outstanding for each object. And it works pretty well if it wasn't for one intractable problem that no one's actually managed to solve so far. And that's the circular reference problem. If you have two objects that each hold references to each other, it looks to the memory manager as if these objects are still alive, yet no one else references them, and so you create a little island of memory that never gets garbage collected. The .NET framework uses a different technology for memory management called mark and sweep, and I'm not going to go into details about how it works, but basically it circumvents entirely the problem of reference counting. Another key thing to providing a robust execution environment is exception handling. You're familiar in VB with on, error, go to, and it certainly gives you some modicum of structured error handling. But still, exception handling goes way further. When an exception is raised in the .NET framework, Every exception carries along a descriptive error message. You can obtain a stack dump from the exception and learn precisely what went wrong and where. And perhaps most importantly, error handling is mandatory in the .NET framework. If you look at how the Windows API has worked traditionally and how languages actually have worked traditionally up until now with C, C++, and so forth, error handling has always been an optional thing. If an API may have a function that returns an error code or a result code that says whether the API worked or not. But unless you actually write code to check the error result, nothing will happen even when it goes wrong. Indeed, your application will, so to speak, muddle on, and then 3 or 4 API calls later, something blows up because of a null pointer or whatever, and you have no idea, how you ended up there. Not so with exception handling. With exceptions, if an exception occurs, and if your application does not handle the exception, then the application will be shut down. It will be shut down in an orderly fashion, mind you, and you have ample opportunities to sort of unroll your state and so forth, but we will not muddle on by default, and that will definitely remove lots of bugs. Type safety is another thing that brings about robustness. In the .NET framework, it is simply impossible to have unsafe typecast. You can't cast a pointer of one type to a pointer of another type. The execution engine will simply refuse to do it. It's impossible to have uninitialized variables. You can't index an array out of its bounds and so forth. A key thing, too, is our zero impact install feature. This is, in fact, one of my favorites. With the .NET framework, when you write an application, there is absolutely no requirement that anything be registered in order for that application to run. You can create a subdirectory, drop the application in there, run it, and when you're done with it, you can delete the subdirectory, and it leaves no trace whatsoever on your machine. That's not to say that applications can't actually share information. We do support another model where you install into the global assembly cache, as we call it, and then applications can share libraries. Another key, I think, innovation in the .NET framework is side-by-side execution, which allows you to run and to have installed on your machine multiple versions of the same application. So you can have application version 1.0, version 1.1, and version 2.0, and you can run them side by side. You can even run objects from these applications within the same process. Now, what this means is that no longer will you have sort of the DLL hell problem that occurs when you install a newer version of some DLL and one of your applications break because of it. Instead, by default, with the .NET framework, your applications simply continue to run against the versions of libraries that they request. So like I said, you can have version 1.0, 1.1, and 2.0 of some database support library, and various applications can continue to use various versions, and therefore, by default, you are ensured that applications will not break when you install newer applications on a machine. Thank you. So the .NET framework is a multi-language platform. From the very beginning of us designing this platform, we knew that we wanted to support multiple programming languages on this platform. It's important for us not to make people learn one single language, but rather for them to be able to leverage their skills with the programming languages that they already know and the code that they've already written. Another key thing here is that in the .NET framework, all the languages are first-class players. I alluded sort of a little bit earlier to the fact that, APIs are not available to VB today unless they are first wrapped as COM objects. That is absolutely not the case in the .NET framework. Any API that gets published on the .NET framework is immediately available to VB or to any of the other programming languages that are implemented on the platform. Indeed, our integration goes much further than anything that really has ever been seen before. For example, you can write a class in one language, inherit from it in another language, and instantiate it from a third language. The integration is that deep. And of course, it also means that the tools are highly leveraged. You actually really only need one integrated development environment and one debugger to use all of these multiple languages. Thanks. Now, we are providing actually 5 languages: VB, C++, C#, J#, and JavaScript or JScript. But in industry and academia, there are a number of languages that have been developed or are being developed currently, including languages such as COBOL, Fortran, and APL. Now, I mentioned earlier that the .NET framework allows you to interoperate with your existing code. Because all of our languages are built on this common substrate called the .NET framework, the level of interoperability that you have between languages that are hosted on the framework it's just so much higher than anything we've seen before. There is really no difference in performance or in capabilities between writing in Visual Basic or in C# or in JScript or in any of the other languages that get implemented on this platform. But it's not enough to just interoperate between the languages in this new world. Of course, there's a lot of code out there that was not written for the .NET framework, and we want to make sure that that code can still be fully leveraged. So the .NET framework provides interoperability with DLLs, with code that sits in DLLs through a mechanism known as pinvoke, or with COM and OLE automation objects. Indeed, any class you write in the .NET framework can automatically be viewed as a COM object outside of the framework. And likewise, any COM object can be automatically imported into the .NET framework and be viewed as a class in there. And finally, through XML and SOAP, we provide probably the best and most flexible way of doing heterogeneous systems integration. So there's lots and lots of interoperability built into this simply because we think that Moore's law has, at least in my mind, Moore's law has already passed us. What are we going to do with gigahertz CPUs and 512 megabytes of memory? You know, back in the old days with 64K or 640K of memory, well, you could sort of start from scratch every time, and it would take you maybe, 6 months to write a program that took up all of the capacity of the machine. So you could get away with it, but today you can't. I mean, customers expect more and more and more, and there's just endless capacity available, and we have to find ways to leverage the software that's already been written. Okay, so now let me switch gears a little bit and talk about web services, about this web service revolution that we think is currently in process and that Visual Studio.NET and the .NET framework are going to be major enablers of. Before we go into demos and so forth, I wanted to just spend a few slides here on explaining my view of what a web service is. And really, sort of in a nutshell, the simplest way of thinking of it, for me at least, is that where HTML is about user-to-machine interaction, so is XML and SOAP about machine-to-machine interaction, but over precisely the same infrastructure. Now, I talked earlier about how distributed computing and connected applications traditionally have been built with technologies like DCOM, Corba, RMI, and so forth. So what is it about web services that make them a better technology for writing these distributed apps? I think there are 3 key drivers here. First of all, XML web services truly leverage the web. They literally run on precisely the same infrastructure stack as HTML applications do today. All the way from the network, all the way up through the HTTP protocol, everything is the same. The only thing that changes with web services is that instead of trafficking HTML, you're trafficking XML as the HTTP payload. But of course, this gives us tremendous leverage of what's already out there. And indeed, if you have a web application already implemented, adding web services to that web application may be as simple as adding a few lines of code or an extra page in the website. The second thing, I think, is that web services allow for truly heterogeneous systems integration. Any kind of distributed application architecture has to support heterogeneous environment. You can't require that the same OS be present on both ends of the wire. You can't even require that the same middleware be present on both ends of the wire. And with web services, while one end of the wire might be the .NET framework, the other end of the wire could perfectly well be an Apache server running a Perl script to parse out the XML. The final thing, I think, is that XML web services allow you to build truly scalable distributed apps. Again, if you look at the traditional distributed app technologies, they're all sort of called object remoting technologies, DCOM, Corba, and so forth. And really the way they make the world look is they try to make the entire world look like objects. It just so happens that some of the objects live on your machine and some of the objects run on other machines. And while that architecture works fine for inter-process communication on one machine or perhaps communication on a local area network, it really runs into problems when you start looking at geo-scale applications where, you know, your client is in San Francisco and you're talking to a server out in New York. Because with these applications, with these older technologies, they basically try to hide the fact that your application is distributed. And you can't really tell when there's latency on the wire. When you make this call, it's going to take a long time to complete. So you tend to hold state alive for long periods of time, which really hurts reliability because you can't do failover. You tend to engage in very chatty communication, you know, where you make a method call on this object, and then he calls you back, and then he goes, oh, thank you, oh, you're welcome, and so forth. And that's all very fine when you're on a single machine, but the speed of light becomes a problem when you're talking out to the East Coast, and you really want to understand what goes on the wire. Now, contrast that with XML web services, where it's almost like, well, the proof already exists that these applications can scale beyond anything that we've seen before, because we already do scale them today with HTML. And like I said earlier, all we're changing here is that we're trafficking XML instead of HTML, but all the infrastructure stays the same. And we know how to scale. We know that it can scale. So what is the foundation for web services? Well, of course, it starts with the ubiquitous communication provided by the internet. And then on top of that, the universal data format that is provided by XML. XML can be used to traffic any piece of data. Now, on top of that, we have a series of protocols that are all varieties of XML. We have XSD for describing types. We have SOAP for describing interactions or invocations of web services. We have WSDL, the Web Service Description Language, for describing web services. And we have the Discovery Protocol. On top of that, then, there is the, if you will, the yellow pages of web services, the registry of services called UDDI. Now, key to all of this is that these are simple and open standards that have broad industry support. These are specifically not Microsoft standards. Rather, these are standards that have all been built with industry partners in standardization consortiums such as the W3C. So how does a web service work? Well, let's say that I'm a web service consumer and I want to talk to a web service. Well, first I have to discover the web service. I have to find it out there in the universe of web services. And I can do that in a couple of ways. I can either go to the UDDI registry and look for web services within a particular business segment or web services that support a particular schema, and it's, the data is sorted in a variety of different ways. But common to all of it is that I get back a link to a web service description language document that tells me about the web service that I found. I could also just go directly to the website of the organization that I'm going to talk to. Let's say I already know what their website is, and obtain a DISCO document or a discovery document that basically is a catalog of all of the web services that are available at this URL. In either case, I end up ultimately with a WSDL file or a web service description language file for the web service. Or rather, I end up with a link to it, and I can then go obtain this WSDL file. And from that, I now can know how to engage in communication with the web service. And so the final step here is actually to go talk to the service using the SOAP protocol with XML payload. Now, the top 3 steps on the slide here are all design time steps, if you will. None of them happen in a running application. Only the last step happens in the running application. But all of the top 3 steps have complete support in Visual Studio. I can, from within Visual Studio, go to the UDDI registry. I can obtain a discovery file or a WSDL file and have Visual Studio automatically create me proxies for the web service so that I simply can call a method that takes a bunch of parameters, and then all of the infrastructure that goes below is automatically handled. So that's sort of a little bit about what web services are. Now, what is it that .NET brings to the table here? Well, if you look at how you develop applications, there are certain application concepts that are always common in your apps. You know, your apps tend to deal with data. There tends to be schema for this data. Your app performs services, i.e., you know, the functions of the application, and there's policy about how the application is invoked. Now, if you look on the web, there are standards, either existing or emerging standards, for these concepts on the web today. Data can be described with XML, schema can be described with XSD, services can be described with WSDL, and invocation can be done using the SOAP protocol. But when you write code, you don't really think about XML and XSD and so forth. You think more about, for your data, you think of objects. For your schema, you think of, well, the classes of those objects. For your services, well, those are the methods of your application, the functions of your application, so to speak. And invocation as well, it's calling those methods. Well, the value that the .NET framework brings is a bidirectional mapping between these concepts that you know as a programmer and use day to day, and the standards that exist on the web. So the .NET framework can, for example, take any object and turn it into XML automatically. And likewise, it can take a piece of XML and turn it back into an object. Likewise, it can take a class and create an XSD schema for the class, or go in the opposite direction. Same is true for methods, same is true for calls. So basically, the .NET framework allows you to think of programming in the terms that you are comfortable with. And then the framework handles the mapping to the infrastructure on the web. To make it a little more specific here, let me just show you what a little web service might look like. Let's say I have written an order processor class that has a submit order method, and the submit order method takes a purchase order object. In order to turn this into a web service, I actually don't have to modify any part of the code. I just have to add an attribute to the code, a web method attribute that tells the system, please expose this method on the web. Now, I might actually want to do additional things like control the format of the XML that goes across the wire, so I could add additional attributes to my purchase order that specifies that when this object becomes XML, please put it into an order, please use an order root tag, put it into this XML namespace, and for each of the fields in my object, I can specify whether I want to map to XML attributes or to XML elements. But key to it is that I can write a little piece of code like this, and I can do it in another language. For example, here I implemented the web service in C#, and I can write a little bit of client code that uses it in VB, where I dim up a new purchase order. I say ship it to me and send the bill to Bill, and do it today, and submit the order. And what happens when I do that is that the .NET framework turns that invocation into SOAP formatted XML, traffics the SOAP envelope and the embedded object across the wire to the web server. The web server, so to speak, reconstitutes the object, does its work, sends back a result that gets turned into XML, comes back and gets turned into objects for me on the client. All of that happens completely automatically. And in fact, let's go take a look at this in a little demo here. So you've seen, on slides here some of the incredible capabilities of this platform. What I'd like to do now is spend the next 15 minutes sort of doing a lap around .NET. I'm going to build a web service, first of all. Then I'm going to test the web service using my browser. Then I'm going to add some data access logic to the web service. And finally, I'm going to build a rich client application front end for the web service. And finally, I'm going to deploy that rich client application. So let's start out. And just to show you that there are absolutely no magic or strings attached here, I'm going to use my favorite editor here, Visual Notepad, and just make it as simple as I possibly can. So we'll fire up Notepad and we'll just write the web service from scratch right here. So we'll start out and we'll say I'm going to write a web service. I'd like the language to be C#, since I'm a little partial. And I'd like the class that I'm implementing to be called my class, or my service, sorry. Now, what I wrote here is a little header that tells ASP.NET that this file contains a web service. And the rest of the file now is simply like a normal C# file. So in here I can say using system.web.services. And then I can write my class, public class my service. And let's say I want to create a method in here called add that takes 2 integers and returns the result of adding them together. And that is all my code right there for my web service. Now, the only last thing I need to do is I need to tell the system to please expose this method here as a web service. And to do that, as I showed you earlier, I simply put a web method directive on the method. So let me save this, and we'll call it demo.asmx. And now let's fire up our browser, and then let me try and hit this web service. So I'll go to localhost localhost/demo/demo.asmx. And let's just take a step back and look at what happened here. First of all, with ASP.NET, every time I hit a web page, ASP first looks to see whether this is the first time that I've hit the web page, and if it is, it compiles it into IL. So what happened here, first of all, was that the class I just wrote got compiled automatically by ASP.NET. Second thing is that ASP.NET notices that my request is coming from a browser as opposed to from a web service client, and so it creates a test page for the web service automatically. And on this test page here, you see it's looked at my code and it figured out that, there's an add method in here in the web service, and I can actually go ahead and call the add method by clicking on the link, and then the test page wants me to pass the 2 parameters, x and y. So we'll type in, say, 32 and 10, and we'll invoke the method. And at that point, the method runs, it computes the result 42, and that gets automatically trafficked back as XML. So that's sort of, thank you, in a nutshell, a very simple web application or web service. Now, if we go back to the test page again, you'll note that not only did ASP.NET automatically extrude this test page, it also did a little bit of analysis on my web service to see if it adheres to all of the standards that are out there for web services. And it actually discovered that I have not put the web service into an XML namespace, which I'm supposed to do if I'm a good boy. So it suggests down here how I might go ahead and fix that in my code. And I'm just going to go say, well, that's great. Let me just copy and paste that little fix here. So we'll grab that and we'll go back to our web service and we'll paste in that little attribute to put the web service into a namespace. Now, the reality is that doing arithmetic operations over the web is highly inefficient. And in most cases, people are probably going to do some form of data access in their web services. And indeed, when I look at how people build data logic into their applications, there tend to be sort of two schools of thought. One is that you model your data as objects. You have a customer object and an order object and so forth. You obtain the data from the database and then you create instances of your objects and you populate the data in there and then you operate on those. Another model is that you simply keep the data in its tabular form. You know, today that would be in a record set with ADO.NET. It's called a data set, but you basically just sort of treat it as buckets of data. I'm going to show you how we support both of those methodologies equally well. And let me start out by looking at the object way of building data access. Indeed, let's say that in my web service here, I want to create a little contacts database that I want to talk to as a web service, and I want to model it as objects. So first what I'm going to do is I'm going to paste in, since I don't want you to look at me typing all of this, a little class called contact that contains a name, address, and phone number. And then I'm going to create a web service that can return a list of contacts. And I'll just paste that in here. Now, of course, in the real world, you know, you're not going to just instantiate these objects on the fly here. They're going to come out of a database. I just wanted to show you how web services can return and operate on structured data. And here you see my getContacts method returns an array of contact objects. So let's try and save this. And then let's go back to our test page. And we'll simply refresh the test page. And you see two things happen here. First of all, ASP.NET discovers that my web service file has been modified, so it recompiles. It produces a new test page. And in this new test page, the error diagnostic at the bottom is gone because I fixed the missing namespace. And I now have a link to the additional method that I wrote, the getContacts method. And let's try and click on that link. And indeed, since it takes no parameters, I can simply invoke it by just clicking the invoke button. And here you see the result, nicely formatted at XML. Notice here how I did absolutely zero work to take this array of contact objects and turn it into XML. Yet here it is, array of contacts with each contact object having a name, address, and phone number field. All of it done completely automatically. Now let's just for the sake of argument say that someone had told me about the particular XML schema that they wanted for this contact database. And let's say that they had wanted the data of each contact to not be trafficked using XML elements, but rather using XML attributes. Now I can actually go back and use some directives in here that control the shape of the generated XML. To do that, I'll first say using system.xml.serialization. And then we'll go down and we will add a few attributes to the fields of my object. Indeed, we will say here when you turn, when you turn this object into XML, instead of making it an element, or when you turn this field into XML, instead of making it an element, make it an attribute called name. And let's do that to the other guys as well. So we'll copy, and then we'll just paste a little bit here, and we will say the address field, turn that into an adder attribute, and then finally take the phone field and turn that into the ID attribute on the object. So we'll save this. We'll go back, and we will just refresh the results page of my web service, which will re-invoke the web service now with the new formatting in place. And here you see the shape of the XML magically changes to use attributes instead of elements. So there's tremendous, thank you. So as you can see, the tool gives you tremendous control over the wire format. Now, the other way of trafficking data, or the other way that applications manipulate data, is that they just create and return full record sets that basically reflect the result of, say, a SQL query. And we can certainly do that also in our web service. In fact, let me go back, and let me add a bit more logic here. I'll add a few more using clauses first. So we'll import the data namespaces, and then we'll grab a little method that we have and paste that in. And this is a little method called getData. It takes a query string, it then creates a connection, it creates an adapter for that connection, and then it creates a new data set and fills it with the result of executing that query. So we'll go ahead and save this, go back to our web service. We'll refresh the test page. You see, again, recompiled, we get the getData method. We can invoke it, and of course it takes a query string, so we'll have to type in something. We'll say select star from customers. And we'll press enter. Now what you see here is the result of that XML, or of that SQL query returned as XML. Indeed, if we go down here first, here you see each of the entries in the table, and there's a customer ID and name, blah, 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 blah. But at the beginning of the XML, there's also a description of the schema of the data. So the data not only contains the actual records, it also contains a description of what the records mean, so that a client application can understand how to display this data. And indeed, let's go try and build a client application that calls this web service. So we'll shut down all these windows here. And we'll fire up Visual Studio. And let's say, create ourselves a new project. We'll create a Visual Basic Windows Forms application. We'll call it Client. And here's our Windows Client Forms Designer. And in here, what we'll try and do in this little client app is we'll call the web service and display the result of the web service in a data grid. So we're going to grab a data grid, put it on our form. We're going to grab a button, put that on our form, down in the corner here. Try and clean it up and make it look a little nicer. Here we go. Now, in order to call the web service in here, we first have to add a reference to it. And as I mentioned earlier, Visual Studio completely automates the step of importing the web service description file and providing a proxy for the web service. So we can simply right-click and say Add Web Reference. In here, we'll just hit our web service localhost /demo/demo.smx. And here again, we see, it tells us here are the services that are available, and we can just say Add Reference and import them. Now we can go and write a little bit of code behind our button, and in here we'll say dim s as new localhost. Since I didn't change the namespace, I'm referring to my web service as the localhost namespace. And here you see statement completion on web services. Here you see the my service object that lives in the localhost namespace, and that's indeed the service I just wrote. So I'll just dim that up as an object. And now I can refer to the web service. And what I'll do is I'll say datagrid1.dataSource. So set the data source of my data grid to be the result of executing the getData method of my web service. And again, here you see statement completion on the web service. It knows that there's a getContacts and a getData method in there. And indeed, when I pick getData, it knows that I'm supposed to give it a query string here, so I'll type in select star from customers. And I will pick the first of the tables that come back. A data set, unlike a record set, can actually return multiple tables, and we'll just pick the first one coming back. So 2 lines of code in order to call the web service. Let's try and run this app. And here's the running app. And when we click the button, we will now invoke the web service. The result will come back as XML that gets put into a data set, and then we put a grid on the data set. Thank you. Now, of course, your job isn't done when you've written a rich client application until you've deployed that rich client. And we actually permit you to deploy them very easily with the .NET framework. Indeed, you can deploy your rich client apps just with a link on a web page. And I'm going to show you how to do that. So I'm going to first go to my client app here. I'm going to go, or to my project, I'm going to go to my properties, and I'm going to change my build output path to be the root of the website that we've been working with. So when I build now, Visual Studio will drop the exe into the root of the web server that I was building. So we'll build. And then we're going to go back to Visual Notepad again, and we're going to write a little HTML page that links to the rich client application. So we'll start out with HTML, and we'll make it H1 so you can all read it, and then we'll say click, and then we'll create an href to client.exe, which sits in the web server's root directory. So click here to run smart client application. We'll close this off. Okay, and we'll save this, and we will just call it start.html. So now let's fire up the browser, and then let's hit this page. So we'll go to localhost/demo/start.html. And here you see the little web page that I just wrote that links to my client application. So when I click here, now it's all happening on one machine, but when I click here, I am actually downloading the application to my local machine and running it out of the internet download cache. So here's the app running, and I can click the button, and it can talk back to the web service. Now you go, well, geez, what about security? Well, this app is actually running in a sandbox at this point that protects it from calling any web services other than web service at the same URL that it came from. It can't create files on disk, et cetera, et cetera. A whole bunch of barriers are in place. And to show you that that's the case, I'm going to close it, go back to Visual Studio. I'm going to try and add an additional button to my application. And we're going to write an event handler that tries to do something bad. Now, we're not going to be too bad, so we'll just try to say create a file in the root directory of this machine. So we'll simply say system.io.file.create, and we'll try to create log.txt in the root directory. We'll build. That deploys now a new exe into the root directory of our web server. We'll go back to our start web page. will link again, which will download a new copy of the executable. You can see we got a new copy because we have 2 buttons now. I can still call the web service. But if I try to create a file in the root directory, I get a security violation. And you see here it says the application attempted to blah, 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 blah. That's not permitted by security policy. Now, the interesting thing is I can actually continue to run because it's all done through exceptions. It's just every time the app tries to do something nasty, it gets stopped. Thank you. So in 15 minutes, that was, a quick overview of sort of all of the functionality that .NET provides, be it for server, client, and so forth. Indeed, the core tenet of .NET is, the triumvirate of clients and servers and services. And just like the .NET framework provides the core infrastructure for developing applications that target these areas, so do Visual Studio.NET provide the complete development experience. In the client space, for example, Visual Studio.NET allows you to create a multitude of different client applications, be it Windows Forms, as you just saw me do, be it web forms, or be it using the mobile internet toolkit to create front ends for mobile devices. In the server space, we provide rapid application development for the server. Just as you've been used to being able to create client applications by grabbing controls from a tool palette and dropping them on the form, so can you now do that on the server, and you can grab things like event logs or message queues onto a business object designer and build your business logic in a visual fashion. We have incredibly rich data access in Visual Studio. We have integrated data designers, query builders, et cetera, and complete support for the .NET Enterprise servers. And of course, as you saw with web services, Visual Studio.NET provides for the entire life cycle of web services through discovery, consumption, creation, registration, and deployment. Now, to give you a closer look at Visual Studio.NET, I'd like to bring up Rob Copeland, who's the Product Unit Manager for Visual Basic.NET.
Good morning. I'm going to show you for a few minutes this morning how Visual Studio.NET makes creating those applications even easier. I'm going to start in the development environment and create a new project. So I click the New Project button, and this allows me to choose what type of project I want to create. Now I'm going to say that I want to create a web service that returns information about books. So I click ASP.NET Web Service, and I think I'm going to call this my Book Info Service. And I click OK. Visual Studio now is going to go contact the web server, create an application route for me, put the files up there that I need in order to create this web service, and then bring me back to a design view. Now this design view is a new feature in Visual Studio.NET that gives me an easier way to use components and classes inside of my components that I'm currently developing. It's very similar in a lot of ways to a form, where I can drag and drop components, set their properties, handle their events, without having to write all of that plumbing code. I can concentrate on my business logic and the code that I want my web service to accomplish. Now Anders showed you how easy it is to create data and return that data as XML from a web service. I'm going to show a similar thing, but I'm going to use some of the richer tools inside of the Visual Studio development environment. I'm going to bring up a new feature in Visual Studio.NET called the Server Explorer. The Server Explorer is a great way to get access to resources on servers that I want to program against. In this case, I've got 2 things here. I've got data connections, so I can look at SQL servers and other types of databases. And I've got a list of servers. Right now I just have the one, which is the machine that I'm on, but I could add others to this list. The thing I want to do is connect to a SQL server and get some data back and then return it when somebody calls my web service. So if I expand this node, I see a list of database diagrams and tables and stored procedures. If I expand tables, here's a books table. This is the one that I want to use for my web service. I can drag it and drop it onto this design surface. VisualStudio.net then automatically creates the components that I need to get the data from the SQL Server. In this case, it's created two components. A connection, which allows me to connect to the SQL Server and execute commands there, and what's called a data adapter. And the data adapter is the thing that actually gets the data back from the SQL Server, turns it into the form that I want, and then puts it into a data set. And Anders talked about a data set just a few moments ago. Now, as I said, this is similar to a form in many ways, except this is really just a class that I'm working on here. But it's similar to a form because I can click on these components, come over to the property window, and set their properties. So for example, maybe I don't want my web service to be called Service 1. It's a simple matter of coming over to the property window and changing its name. I'll call it Book Service. By default, the data adapter that was created for me will return all the records from the database. I really don't want all the records. I want someone to be able to tell me what book they want information on. So going back over to the property window, I can click the Configure Data Adapter link here, and this brings up a wizard that's going to walk me through this. It asks me which data adapter I'd like to use. There's only one on here, so I'm going to choose the default. And now it asks me how I want to update the data and get data from my SQL Server. By default, I can use SQL statements, but I'm going to choose Create Store Procedures so that they're living on the SQL Server and I get better performance and scalability. And VisualStudio.net will automatically create those stored procedures for me. When I click Next, I can see what the default select that the wizard wants to use is, and again, it's going to return all of the records, and I really don't want that. So I can click Query Builder, open this up, and the ISBN is the thing I'm going to have customers ask me for, and then I'll return data on a given ISBN. So I'm going to go to the criteria field here and type equals at ISBN. And that's going to say, ask me for an ISBN or let me ask for a certain ISBN number and then only return that book. I click OK. Now the wizard wants me to name the stored procedures, and it's going to automatically generate these for me. So I'll call the select one Book Select, Insert, I'll call Book Insert, and so on. And then I click Finish. VisualStudio.net connects to the SQL Server and generates the stored procedures for me automatically. So now I've got an easy way to connect and get a single book back from my SQL Server. Now another great thing that I can do using the property window here is by default, the form of the data that's coming back from SQL Server is the names of the columns in the database. And a lot of times my DBA names things in ways that I don't really want to use in my object model. So I can go over to the Table Mappings property and bring up a dialog that allows me to name the tables the way I'm going to use them from my program so that I can have an object model that's much more to my liking. So here I see that they named the title in all caps, and my object models never have all caps, so I'm just going to change it to a regular proper casing. And down here for the price, they stuck this MNY in front of it to denote money, I guess, but for me, I just want it called price. So I'll click OK. Now I've got this thing configured the way I want it so that I can interact with my SQL Server very, very easily. I haven't written any lines of code yet. VisualStudio.net is taking care of all of these property settings and all of the work necessary to make these mappings happen for me. Now one last thing that I want to do is go back to my Server Explorer. And Anders in his last slide talked about RAD for the server a little bit. And that's a set of features that VisualStudio.net uses to allow you to more easily program against servers. The Server Explorer is part of that set of features, but we've also created a set of components that make common server tasks very easy. In this case, I want to use a performance counter to count how many people are hitting my web service, so I can see if it's got the capacity that I need, if I need to add more machines or change something about it. So I'm going to go and expand my server, and I can see that I've got a list here of event logs and message queues and performance counters that are currently on this machine. If I expand the performance counters, boy, there's a huge list. .NET Framework added a bunch of things. If I scroll down, there's a bunch of SQL Server performance counters, but none of these are really what I want for my app. So VisualStudio.net makes it easy for me to create a new category of performance counters. I can right-click and say, Create New Category. I'm going to call this the Books category. and then create a specific counter in that category. And in this case, I'm going to call it query count, to count how many queries I'm getting against my web service. So I'm going to hit OK. Visual Studio goes out and creates that performance counter on this machine for me, and it could do the same thing on another machine on the network as long as I've got privileges on that machine. Now I can see that it's created this category, and here's the query count counter. In order to use it for my application, I simply drag it off and drop it onto this surface. And again, I've got a component now that I can easily use the property window, for example, to change read-only from true to false, so I can actually write it. And I could do a number of other things here. But the real benefit here is that you don't have to write the code to instantiate these components and set their default state. You do that visually, and then you can concentrate on the code that you want to write for your web service. Well, now that I've got all of these components set up, I'm going to double-click on the surface, which is going to take me to the code behind, much the same way that I go to the code behind a form. And in here, I'm going to essentially do what you just saw Anders do. I'm going to create a public function. So I'll say public function get info for. And the information I'm going to return was a book. And I want people to send me the ISBN number. And they can send that as a string. And this function is going to return, it's going to return something that I forgot to put on here. Let me go back. One last thing that I want to do. As Anders talked about, and I talked about a little bit, data sets are the component that actually contain data when I execute queries against databases. And the data sets are disconnected from the database and sent across as XML. And in this case, I need to tell this data adapter to generate a data set for me so that I can use it. So I'm just going to right-click and say Generate Data Set. I'm going to tell it that I want to call it book info. And now here's a list of the tables that I could use inside my data set. A nice thing about the data set is it can contain more than one table, and it also can store the relationships between tables. In this case, I've only got one. I'm going to tell it to go ahead and add this to the designer so I can use it easily from within this web service. There we go. Now I've got my data set called bookinfo1. I'm going to switch back to my code, and now I can finish this and say I want to return bookinfo, which is that data set. So now I've got a public function, and all I need to do is a couple of things here to invoke my SQL data adapter, call the SQL server, get back the data, and return it. The first thing that I need to do is tell the SQL data adapter what the ISBN number is. If you remember, I told it that I wanted a parameterized query. So here I go in and I tell it to take the select command. There's a parameters property here that lets me say which parameter do I want to specify. I want to specify the ISBN, and I want to set its value to the ISBN that someone's going to pass in. So that sets up the stored procedure so that I'm ready to call it. The next thing I need to do, is not whatever I just did. I need to do SQL data adapter, and it's got a fill method. This tells it to fill a data set, and the data set on my web service was called bookinfo1. I wanted to also bump up my performance counter, and that's already on here and instantiated for me. All I have to do is say performance counter 1 dot increment by 1. And now I'm done. I just want to return my data set, which is bookinfo1. And now I've got a fully functioning web service, and I used a lot of the functionality in Visual Studio to add quite a bit of value with very little code. If I press F5, Visual Studio will automatically launch the browser and take it to my web service and show me the same page that Anders was showing you that allows me to test out my web service. But it doesn't show anything because I forgot to put web method, which is the attribute that tells Visual Studio that this public function needs to be exposed as a web method. Now when I press F5 and it hits the web service, it's got my get info for. I can go ahead, it's going to ask me for an ISBN number. Luckily, I just happen to have one in my clipboard, so I don't have to remember to type that in. I click Invoke. It calls the web service, which connects to the SQL server. And as Anders showed you, I get the same type of thing back. I get a set of XML back. So it's very easy to make use of server resources, SQL Server resources, performance counters, and a whole myriad of things that are listed in the Server Explorer. Now that I've got my web service, Anders showed you how to create a rich Windows client using Visual Studio.net. I'm going to create a rich web client using Visual Studio.net to use this web service. I'm going to go over here and add an existing project that I've already created. And it's at HTTP localhost book application. And if I open this up, I've got a simple web page. It's not very pretty. I haven't had a chance to get a designer to look at it or anything yet. But it's got a text box that's going to allow me to type in an ISBN number. And it's got a couple of labels here to put the author and the title of the book. Now, the first thing that I need to do, and Anders showed us this just a moment ago, is tell Visual Studio.net that I want to use a web service. I go to the web references node over here in the Solution Explorer, and I choose Add Web Reference. And it's already in my drop-down list here, so I pick it. Now, from here, I can also check out the web service and see how it works, just like I did when I was in the browser. But at this moment, I'm just going to say Add Web Reference. Visual Studio automatically creates all the plumbing that I need to call that web service, and I call it just as if it were an object. So I have a very familiar programming model. I'm going to double-click the button on the form, and now behind here, I'm going to create a variable called WS, and it's localhost .book service. I need to create a variable to contain the return value, the data. So I'm going to say dim data as, now again, localhost and book info was my data set. Now to call the web service, I simply can say data equals ws get info for. Now I'm going to take the value out of that text box that was on my web page, textbox1.text. And call the web service with it. That's going to return and fill this data set with data. And then to put the data into the labels, I've got my author label. I'm going to set the text value to data. Now, as I said earlier, data sets can contain more than one table. So in this case, I need to say that it's data.books because that's the table. I'm going to say sub 0 because it's only going to have one row in it, and sub 0 is the first one. And now I can use statement completion to find the fields from the SQL Server data that I want to use. In this case, author last name. And then I'll do the same thing with the title field. Data.books sub 0 .title. Now, one last thing I need to do is tell Visual Studio that this is the project I want to run when I press F5. But one of the added benefits that Visual Studio has is very rich debugging. So let's just take a look at that real quick. Let's say that my web service and my web application isn't working properly and I need to find out what's going on. I can set a breakpoint in this code behind my web page. I can go back over to my web service and set a breakpoint in my web service. And I can even go back into Server Explorer, go to the stored procedures. These are the ones that were generated for me. Open up the select stored procedure and set a breakpoint there. And now, when I press F5, Visual Studio is going to automatically launch the browser and take me to my web application or that web page that I just created. Here I can go ahead and paste in my valid ISBN number and hit get. Now when I click get, the code that I wrote behind the button is going to execute, but I had a breakpoint there. So this code could be on another machine. I'm still going to step into it from my Visual Studio development environment. I can use all of the rich debugging tools of Visual Studio. I can press F8 and step. Now this next call is actually calling the web service, which could be on yet another machine. But I can step onto the web service, which is going to give it a call. All of a sudden I hit this breakpoint. I can hover over my values and see that it's passing the ISBN in. I can step here. Now this next call, which is the fill on the data adapter, calls the stored procedure on the SQL Server. So when I step onto that, I actually step into the SQL Server and onto the stored procedure. And again, I still get rich debugging. I can see what the values are and use the rich interfaces of Visual Studio to have a great debugging experience. And I can continue F8 and just keep stepping through. I'm going to press F5, which is going to bring the browser back up, and finish this. I think if I press F5, there we go, and finish it and fill in these fields from the SQL Server. So I get a very good end-to-end. Thank you. So I get a great set of features to allow me to easily create these applications and then debug them. Now, one last thing that I want to show you that I'm really excited about is a new feature in Visual Studio Enterprise Architect Edition, and that's Microsoft Application Center Test. So I've shown you how easy it is to create these applications and debug them, but I also want to show you how it's easy to test performance capacity on these things. I've got my performance counter running down here, and I'm going to go ahead and add that performance counter that I created earlier. Actually, I need to refresh it, so I'm going to start it up again, get rid of these default things here. There's the books category in the query count. And you'll notice that when I put that in there, I've got a count of 2, because I've called this thing twice so far, and my performance counter is actually working. But what if I want to see what happens when lots and lots of people are calling this thing? I'm going to go in and start Application Center's Tests UI. And what this allows me to do is create tests to hit my web service for me automatically, so I can see what kind of performance I'm going to get. I'm going to right-click on Test and say Create a New Test. And I can create an empty test or choose to record a test. And what I like to do is record a test. It's going to be in VBScript, which is fine for me. And I'll say Start Recording. Application Center Test starts up the browser for me. Now it's recording what I'm doing. So I'm going to go in here, choose my web application that I just was running, paste in my ISBN number again, choose Get. It's going to go out and hit the web service, get the data back, put it on the page. If I go into my performance counter and look, it's bumped up to 3 because my web service recorded that. But if I go back to my Application Center Test, I choose Stop Recording. Choose Next to give it a test name. I'll call it Book Test. And choose Finish. Now I've got Book Test over here in my list. I can look at the script that it generated if I want to. I can right-click on it, and there's a whole set of properties here where I can set how many browser connections do I want, how many users do I want to simulate, how long do I want the test to run. I'm just going to leave those at default and click Run. Starts up this little app and shows me what's happening. If I go to my performance counter, gosh, I've got a huge spike all of a sudden, because now we can see I'm up to, if you can see it, it's kind of small, but 400, 500. So it hits the web service over and over and over again, and I can come back to the Application Center Test and get a little graphical printout of how many requests per second, any errors, and that sort of thing. So this makes it very easy for me to test my web service and see what kind of capacity it has. All right, well, I'm glad to be able to show you this morning how Visual Studio.net makes creating .NET applications very easy, easy to debug, and then easy to test. Thank you very much.
Thanks, Rob. So today, in Bill's keynote, you saw several customers that have already built and deployed applications on the .NET Framework, Visual Studio.net. Hopefully, Rob and I have showed you how easy it is to get going with your applications, how easy it is to use web services. And there's a lot of information that you can draw on out there already. Over 150 books and magazines, training, more than 20 languages implemented on the .NET Framework, more than 65 Visual Studio integration partners, a whole slew of component vendors, and more than 25 ASP.NET application hosting companies that can host your ASP.NET applications and web services. So, start writing .NET applications today. Everything is there for you to do so. And on behalf of Bill and myself and the entire Visual Studio development team, I really want to thank you for being here at this exciting launch. And I hope you have as much fun using this product as we've had building it. Thank you.